It is in our power to have no opinion about a thing, for things themselves have no natural power to form our judgments. An error is just an event. Our judgment makes it a problem. You've just spun up an API server, but notice we've deliberately started it without the P option. You run your Python script to test it, and you get a connection error. What do you do now? Is the problem in your script, in Docker, or somewhere in the network? This video is for you if you're tired of guessing. Have you ever faced a problem like this? If you want to move from guessing to diagnosing with precision, you're in the right place. Okay, here's our situation. Our Docker container is running. Now, I know what some of you are thinking, why not just use Netcat or PowerShell to test the port? And you're right, those are often faster for a quick check. But the goal today is to diagnose this using only Python to really understand the mechanics. We'll look at other tools in a future video. So, with that said, let's try to connect with requests. I'll skip a detailed explanation of the request module itself, but if you have any questions, let me know in the comments below. We expect this to work, but a generic error that hides the specific cause. To get a precise diagnosis, we need to go one layer deeper. In a real-world scenario, you'll often only see your side of the connection, so let's isolate the problem using the socket module to test the transport layer. We'll use the socket module, which is what requests uses internally, to handle just the TCP connection ourselves. This direct approach will help us distinguish between different types of failures, like a connection refused error, port is closed, versus a timeout error, network routing issues, giving us clearer insight into what's actually going wrong. First, let's run our test against the broken Docker setup. Connection refused error. This is a crucial clue. It means our packets reached the target host, and something there actively rejected the connection. This typically happens for two reasons. One, the OS itself rejected it, because no application is listening on that port. Or two, and this is very common, a firewall on the host or in the network is configured to explicitly reject the connection by sending back a TCP reset packet. Getting an immediate RST is a strong indicator of either a closed port or a firewall reject rule. But what if we see a different error? Let's try connecting to an IP address that doesn't exist on our network. A timeout error tells a completely different story. It's like knocking on a door and getting no answer at all. This means our SYN packet went out, but no response, not a SYNAC, not a RST, ever came back. This silent failure is a key piece of evidence. It strongly suggests a routing issue, the host being completely down, or, very importantly, a firewall configured with a drop or deny rule, which silently discards our packets instead of actively rejecting them. Knowing the difference between a reject and a drop can tell you a lot about the firewall's policy. And for network engineers, here's the key takeaway. What socket shows you as an error is what Wireshark shows you as packets. A connection refused error corresponds to seeing a TCP RST packet in your capture. A timeout error corresponds to seeing your outgoing SYN packet with no SYN ACK in response. However, in real-world networks, you might occasionally see a delayed RST from intermediate devices cleaning up connection states. But if your app times out first, you'll still get a timeout error. Based on our connection refused error, we know the problem is a server-side port issue. Let's look at our Docker command again. We forgot to map the port. Let's fix it with the P option. So, what this process shows is that the initial connection error wasn't the real story. It was just a symptom. The tool we chose determined the quality of the information we received. By choosing a lower-level tool, we chose not to accept that vague initial report. Instead, we gathered more precise facts from the transport layer, which led us directly to the root cause in our environment configuration. That shifting perspective, from accepting a symptom to investigating the source, is what turns a frustrating bug into a solvable puzzle. Honestly, this approach has saved me countless hours of frustration. Instead of fighting with vague error messages, I can actually see what's happening at a network level. Thanks for watching.